Number 48, an hourglass composed of two identical cones is 12 centimeters tall. The radius of each cone is 3 centimeters. If you want to fill the bottom half of the hourglass 2/3 full of salt, how much will you need? And so what I'm going to do is I'm going to just do kind of a rough picture here of my cones of what an hourglass would look like. And they're identical, which means they're congruent. The height is 12 centimeters. And I know that the radius, there's my height. The radius of each cone is 3 centimeters. And we want to fill the bottom half, the bottom cone. So I'm just going to focus on the bottom one here, 2/3 full of salt, which if we fill something that's volume, since they're identical, they have the same height, so we would take half of 12 is 6. So the height of the cone itself is 6 centimeters. And like I said, I want to find volume of that cone. So volume is 1/3 pi r squared times h. I need the radius, which I have that's 3 centimeters. And I need the height, which we said just one of those is 6 centimeters. I'm going to fill it in, and that's going to give me the volume of the whole cone. Not the whole hourglass, but just that bottom cone there. So volume is 1/3 times pi times 3 squared times the height. Oh, the height is 6, sorry. And that gives me a volume of 56.5 centimeters cubed. That's the volume of the cone, but I'm concerned about how much is 2/3 of that, because I'm going to fill it 2/3 of the way with salt. So the salt is 2/3 of the volume, so I'm going to take 2/3 times 56.5. Just multiply by 2 and then divide by 3. And I end up with 2/3 of the salt with salt is 37.7 cubic centimeters of salt. So it's the salt in volume. (49) in the figure, segment A prime B prime is the image of segment AB after a reflection of line K. We just don't know what line K is. A says find, there's A down at the bottom, find and name 2 points that line K passes through. So to reflect, that means it's going to be a point to be reflected, it's going to be on equal sides of a particular line. So I'm going to draw a line between A and A prime, and I'm going to put a point at the middle of that. Which is right there. And so that if that were the point of reflection, where I reflect across, A would reflect straight across that to A prime. So these would be congruent. I'm going to do the same thing with B and B prime. And put a dot there at the middle as well. And so that those segments are congruent. I could draw a line through those 2 points, those 2 red points, and that would be the line that passes through those 2 points, and that's the line that it reflects across. But my 2 points that the line would pass through would be 0, -2, and 2, 0. So I could put a line through those. And that would be my line. Right there. C, it says graph line K, which I just did, and the point C, which is 3, -2. So I'm going to find 3, -2. Right there. and show its image as a reflection in line K. So if this is point C, the image would, or the reflection of that would go across the red line, and it looks like we're about 1.5 diagonal units across. So C prime would end up being right here. And C prime looks like it lies at point 0, 1. C prime. Number 50. From the top of a 210-foot lighthouse located at sea level, a boat is spotted at an angle of depression of 23 degrees. It says, draw a sketch to represent the situation. So we have a lighthouse. I'm just going to draw a line for our lighthouse, and I'll just say that that's what that is. And it's 210 feet tall. And it says at the top of that, so we're way up here at the top of our lighthouse, and we look down and we see a boat. So there's our boat down here. The angle of depression is represented when you're looking straight across and then you look down. And so that's our angle of depression, which is 23 degrees. It says, use the angle of depression to find the distance from the base of the lighthouse to the boat. So we'll finish off and we have a right triangle here. The thing that I know about angle of depression and angle of elevation is that they'll be congruent within the same situation. So this angle is also 23 degrees. And I'm going to use, I'm going to find this value right here, the distance from the lighthouse to the boat. I have an opposite side to my angle. I have an adjacent side to my angle. So I'm going to use tangent to help me get the distance between the lighthouse and the boat. The tangent of 23 degrees is equal to 210 over x. And then we've already said that when we have a denominator or a variable in the denominator, there we go, that they end up kind of switching places as we go through the algebraic process, and they gives me x equals 210 over the tangent of 23 degrees. And that is 494.7. So now I know what the distance is from the lighthouse to the boat. And that's 494.7. And then the other piece of information it wants us to do is to use the Pythagorean theorem to find the shortest distance from the top to the lighthouse, top of the lighthouse to the boat, which is really our hypotenuse here. I'll call that, actually I'll call that C for hypotenuse. Because I have side A and side B, we can use Pythagorean theorem. Our legs are 210 squared plus 494.7 squared equals C squared. If you work that out, add them, take the square root, you end up with C, which is the hypotenuse, is equal to 537.4